Okay, so we're going to focus on Module 1. This is going to be an introduction to kinematics and displacement analysis. So in this one module, we're actually going to be covering 2 chapters, and it's really a good comprehensive introduction to kinematics. So I'm going to go to kinematics, or Module 1, Part 1, Introduction to Mechanisms and Kinematics. You're going to notice here that it says read chapter 1 in the machine and mechanisms textbook, but I also have a PowerPoint presentation here. This is a PDF version. So I'm going to pull that up on my computer. And you're going to notice that we're going to then walk through. I want to let you know that in this class, we are going to be covering many of the chapters that are in the book, but we don't cover each and every section, each and every example in each and every chapter that we look at, okay? So your PowerPoint, or the PowerPoint that I create, is going to help for you to focus on the sections that you're responsible for, okay? So that's why when I do the lecture, I might not be covering, section 1.6, and it's not a mistake. It's just that's not that important, and we're going to focus on the things that are most important to help us, number one, do the assignments, but also prepare you for the next step, okay? So just be aware of that. Okay. So when I say read chapter 1, I don't necessarily mean read it front to back. Use the PowerPoint as your guide to what sections and examples you would be responsible for. Okay. So as we look here, we're going to be looking at chapter 1. So at the beginning here, it tells us, it kind of identifies the objectives that we have for this chapter and what we're going to be doing. So first and foremost, we want to explain the need for kinematic analysis of mechanisms. Like, why are we going to do that? Okay, why is that important to us? We want to define the basic components that comprise a mechanism. We want to be able to draw a standard kinematic diagram, okay? Taking a complex machine and kind of simplifying it into, just a very, if you would, dumbed down diagram so that we can do what we need to do and lay things out. We want to be able to compute the number of degrees of freedom of a mechanism. And then we're going to be spending a little bit of time making sure that we know how to identify a 4-bar mechanism and also a slider crank mechanism, because those are the most popular that we're going to encounter. So first of all, kinematics. Kinematics is the study of motion without regard to the forces that cause it. Okay, so kinematics is not about how much material do I need. It's not about what is the deflection that we're going to see on that. That was strength of materials. That was statics. Okay. In kinematics, we are only worried about motion. Okay. And kind of taking motion a step further, how much space do we need? Okay. It's the layout work that we do for designs that we need to function in their final form. Okay. So we're going to be focusing on position, displacement, velocity, and acceleration. Okay. Notice we are not worried about forces. We're not worried about materials. Okay. So just motion and displacement. Kinematic analysis is going to be our first step. Like I said, it's the layout work that we do. It's kind of like that before we start getting into things, just kind of figuring out where we're at. Now, when we start looking at machines and mechanisms, a machine is going to be a device that's used to alter, transmit, or direct forces to accomplish a specific objective. So down at the bottom here, I've got a chainsaw. The chainsaw is a familiar machine that directs the forces that are inside the chainsaw to be directed to where the chain is going to actually cut wood. Okay. Now, a mechanism is going to be a mechanical portion of that machine that has a function of transferring motion and force, okay, from the power source to whatever the output is. So a mechanism can be considered rigid parts that are arranged and connected so that they can produce the desired motion that we need for that machine to accomplish, okay? So a chainsaw, for instance, the mechanism takes the power from the small engine and then it delivers it to that cutting edge of the saw. All right, that's its job, if you would. And the mechanism required to do that is what we would be interested in focusing on. Now, kinematics. Kinematic analysis is going to involve determining where we're at in space. Where's the positioning of a particular mechanism or element? What is the displacement? That means, like, how far did we move? Okay, displacement is, okay, if I start here with point A and then I move around, what happens to the other things? How are they displaced from where they were at originally? We want to know what the rotation might be, maybe a rotation angle. We're interested in how fast something is going. What's its velocity? And then also what's its acceleration? What you'll notice missing from here, or actually I'm going to ask you, do you notice anything missing from here? It starts with an F. We don't see force on our list. We don't, and that's by design. As I said earlier, that's a statics question. That's a strength of materials question. We are worried only about the very first steps in our design process, which really deal with position, orientation, displacement, speed, acceleration. And then after we have this done, then we can start figuring out, you know, what the material is going to be. How much do we need? What are deflections going to be? What are the forces that need to be transmitted? Okay. So, so this is not that. This is before that, actually. Let's look at an example. This is figure 1.2, but I do have a copy of it here. This is an adjustable height platform. Okay. And the kinematic analysis would answer questions like, for instance, you know, in regard to this platform here, what is the significance of the length of the legs that support that platform? So we've got these legs that are right here. They actually cross, okay, one another. And it's asking, okay, what is the significance of that leg, the length? If I make them longer, what will happen to maybe the height of that table? If I make them shorter, what will happen to the height of the table? And depending on how much I make them shorter by, how much shorter would the table actually be? Would it be a one-to-one relationship or not? Okay, that's what kinematic analysis is all about. Another question it might answer is it necessary for the support legs to cross and to be connected at mid-span? I don't know. So then you start moving things around, kind of arranging things, changing, you know, where the connections are going to be, and see what those ultimate displacements would be based on moving the elements around. Another one might be, how far must that cylinder extend to raise the platform 8 inches? So if I wanted to go from where it's at and 8 inches higher, the cylinder that's here, and there's actually a cylinder on the one that's there that's missing on this one, but there's a cylinder there that would actuate the motion of those two legs. How far does that cylinder have to go? Well, okay. So those are the types of things that kinematic analysis is going to help us with. Okay. It's those initial questions that we have about the operation and its final function. Notice we're not dealing with forces. I can't emphasize that enough. And I keep kind of saying that over and over again in the beginning here, because too often we want to jump into worrying about those forces and materials and all that kind of stuff. But that's not where we're at in kinematic analysis. We're only worried about the function of, or the motion and what displacements or how much space something's going to have to take up. Okay. So let's talk about some terminology that's going to come up. First of all, we've got linkage. Linkage is going to be a mechanism where all the parts are connected to form a closed chain. Okay, and we'll see kind of examples of this a little bit later, but that's going to be the formal definition of a linkage. Now, a frame is going to be one of the links in that linkage that is going to remain stationary or not move. Now, sometimes a frame is going to be something that's obvious. A frame is going to be like, I'm going to bolt this down so that it doesn't move. Okay. And then you can kind of be like, well, that's the frame that's going to be where everything kind of attaches to or is relative to. Sometimes in the case of hand tools, and it's going to be an example we do a little bit later, is that we have to identify what the frame is, kind of like hold it up and be like, okay, everything is going to be relative to this part. Okay. So whether it's identifying the frame and we assign it, or it's kind of obvious based on how it's actually going to function, we want to, identify where that frame is and so that everything moves relative to it. Then links are going to be the individual parts of a mechanism. And then a joint is going to be a movable connection. Many times these joints are going to be pins, and then something is going to rotate relative to it. Okay. So, so we are going to look at also a simple link is going to be where we're connecting only two items at one joint. And then a complex link is where we have more than one connection. So if we look at page 3 in our book, so I'm going to pull this up here. This is where we're going to see a couple different types of these linkages. So first of all, this one is considered a simple joint. A simple joint is going to join just 2 elements, and you'll notice that they are joined by a pin. So as we look at link 2 relative to link 1, they can rotate about that center on that pin, okay? So that's called a pin connection or a pin joint. The other one that we have here is a sliding joint. Here we have this block, they're calling it link 2. And link 1 is going to be the place where link 2 is going to follow along, and it is not rotating. So in the case of the primary joint, which is a pin, we have rotation between the 2. In this case, we have linear motion occurring between the 2 types of elements. Okay. And then down here, we have a couple different types of joints. Or I'm sorry, the different types of links. This is a simple link. A simple link is where we have one link that has just 2 connections on it, okay? That's a simple link. A complex link is where we have a single link, but we have 1, 2, 3, or more connections to it, okay? So complex and simple. And then the other 2 types that we'll be talking about a little bit later in the course is higher order joints. Okay, these 2 have higher order joints. One is going to be a gear and the other is going to be a cam. So they're treated a little bit differently. And like I said, at the beginning here in these first sections, until we get to gears and cams, we won't be really addressing the higher order joints. We're just going to be working with simple and complex. Okay. Go back to my PowerPoint. Now, a point of interest. A point of interest is going to be a point on a link for which we're going to be interested in what's going on there. Kind of is a circular definition. But what this can be is this can be a point where as it's going through its motion, we're concerned about interference. Okay, even though it might not be where the actual connection to another joint is, but if there is something kind of sticking up like a handle and it's going to be going around in a circle, and we've got to figure out, like, we don't want it to hit something on the outside, or we want to design so that it's going to have clearance, then we want to also draw that point of interest in there. So, so being interested in displacements or accelerations or velocities of that point of interest are going to be things that come up along the way. Now, the next section here, which is 1.5, starting on page 4, we're going to be talking about kinematic diagrams. Kinematic diagrams are going to be simplified versions of, or stripped down versions of, a complex machine. So our purpose is to represent the variables that we need to effectively identify or relay the primary function of that mechanism. So if we look down here on the left-hand side, this is called a toggle clamp, and it's used in tool design to hold parts down. So you're going to notice here that we have the hold down over here and we have the handle here. So as that handle rotates up, this part also goes up. When the handle is pushed down, it forces this down as well and puts it into its clamped position. So what we have here is we have a series of links. So we've got a link going out to the hold down, if you would. We've got the link for the handle. And then we've got this area right here, which is going to be our frame, because that's going to be what actually stays stationary in this operation. So over on the right-hand side, you're going to notice that this is a simplified kinematic diagram of the mechanism that we see here on the left-hand side. If we go over on the right-hand side, it almost looks nothing like the toggle clamp that we see on the left-hand side, but it doesn't have to. Because when we are interested in just understanding what the position of elements are, what's its motion, and what its displacement is, we don't need to draw all the details that we see here. And that's really, again, that first step in the design process. It's the layout work that we're going to do. Okay, so you'll notice here that point Y is a special point of interest because this is the end of the handle. We kind of want to know, if I'm going to be actuating that by hand, how far is that going to be and how far out is that going to be, so that I don't want to interfere with other things, right? The same thing with the front end of our toggle clamp. That clamping surface right there is identified by point X. How far is that going to go down when I move my handle? How far is it going to go up when I move the handle in the opposite direction? So in this case, we actually see two special points of interest, but you'll notice that this looks very much simplified compared to what we see over here. So again, a kinematic diagram is a representation of the motion, the displacement, the function of a more complex mechanism, okay? So the first example we're going to do here, and our focus in chapter 1 is learning how to create those kinematic diagrams, okay? How to create those kinematic diagrams. So let me just peek ahead here for a second. So if we look at example 1.1, example 1.1 starts on the bottom of page 6. So I'm going to scooch out here for a second, kind of come down. I'm going to zoom in. And this problem, what it wants us to do is it wants us to draw the kinematic diagram of the shear that we see right here, okay? So as we look at the side view of the shear, you're going to notice that the operation occurs right here. You're going to notice that we have this blade that is attached to a handle through what we're going to call a connecting rod, and it is constrained to just go up and down along, if you would, the left-hand side or the right-hand side of that angle bracket, okay? And by going up and down, it's going to then shear through any material that is down below, and then we pull it up so that we can put the material back in place and then maybe shear off another piece of material. It is operated or actuated by the handle that we see here. So if we pull this handle up, it's going to pull the mechanism up or the blade up. And then when we push it down, it's going to push that blade back down and then through the material. Okay. So what we want to do is we want to simply, nothing else, just draw the kinematic diagram that represents this mechanism. Okay. Now for this case right here, what we're going to do is we're going to walk through the process and we're going to actually draw it by hand. Okay. First. But I'm going to take the approach of, we're going to kind of start at the end with the process. Okay. So I'm going to kind of zoom in here and I'm going to go back to my PowerPoint. The PowerPoint process here, or the PowerPoint, for example, 1.1 identifies the process that we're going to take in order to get this solution or to get to the finished diagram. So the first thing we want to do is we want to determine where is the frame. Okay, where is the frame? So as we look at this diagram, okay, and I'm going to go back over here, we want to see what are the parts that are not moving. And one of the big clues sometimes are parts like we see here, it's bolted down to something. So you're going to notice that we have two bolts identified here, okay? And the frame then would be this element and this element right here. Okay, that's going to be the frame. Those things aren't going to be moving. Okay. So when we look at our kinematic diagram over here, let's look. Okay. To identify what a frame looks like, there is a standard symbol. And that standard symbol is this. It's going to be a half circle that's going to go down. And it is going to attach like this goes, looks like it doesn't move. And then this is going to be like where the joint is going to connect. So this is what a standard frame symbol looks like in kinematic diagram. And we're going to notice it right here in the diagram. Okay. Now we're going to be drawing our kinematic diagrams on AutoCAD. All right, so we're just going to walk through this process first. I'm just going to be identifying these things and you're just going to be sketching it, but we're then going to translate this to actually drawing it in AutoCAD. Okay, so that's going to be our frame. Now, the other thing about the frame is we identify the frame. It starts with the number 1. The frame is always going to be 1. And it's going to be the first link as we identify the links in a mechanism. Okay, so the first link is always going to be 1 and number 1 is always the frame. So if we're sketching this out, like I said earlier, the first thing we're going to do is we're going to draw that symbol. So again, I'm going to sketch this, try to make it look. There we go. And kind of at the center. So that's going to be my frame member. And we're going to call this number 1. When we call out link numbers, they're always going to be a number with a circle around it. Okay. A number with a circle. Now, the next thing we're going to do, let's go back to our process. So we identified where that frame is. Then we're going to identify the type of each one of the links or joints that we have. Now, table 1.1, starting on page 5 to page 6, is the list of all the different types of joints and links that we can have. So I'm going to go underneath there. And starting on page 5, table 1.1, symbols used for kinematic diagrams. So the first one here, we have a simple link. As we said earlier, a simple link is going to be a single link with no more than 2 connections. Okay, and these connection points on this particular link are at the very ends. To represent that, it's simply going to be a line with filled in dots at the end to represent the joints. And the joints are where we're going to then connect another link. Okay, so this is a simple link. The next one is a simple link, but it's got a point of interest on it. So you'll notice here that we have this like connecting rod that has this dog leg in it. Okay, that's what this little bend is. So instead of just showing it as a straight line from end to end here, although that is a straight line distance, we would just simply show the little bend in the connecting rod here to represent that, because as it's maybe in its motion, we want to make sure that it doesn't interfere with other elements. Okay, so this would be just then if there's a point of interest that we want to identify on a simple link. Again, it's a single link with no more than 2 connections, okay, which we have here. The next one is a complex link. In this case, we have a single link, but there are, in this case, 3 connections to it, 3 joints that are on it. So that becomes a complex link. The next one is going to be a pin joint. So when we have 2 links that come together and they share a connecting point that they rotate about, which is a pin, we are going to represent that with 2 lines and it comes together right at the pin. Notice we don't put the details of which one is longer or which one is, coming in which, we have no thickness here even. It's just identified as a line and they're just connected at their endpoint through that pin. Okay, the pin is going to be a filled in dot in each one of the cases that we see here. Okay, so when we represent this in AutoCAD, we're going to duplicate that. Then as we turn the page, the last one we're going to talk about is going to be a slider joint. A slider joint is when we have motion that is going to be linear and not rotational. Okay, so in this case, a very common one is going to be like a linear bearing on a rail. And so we would simply show this as a rectangular box or block that is going to then move along, in this case, a horizontal surface. This might be vertical. This might be at a different angle. Okay, but it's going to show our slider moving only in a linear direction. So those are the different types of links that we're going to apply here. So what we do is we start where our frame was. So remember, this was the point where our frame started. So what I like to do is whatever's connected to the frame is where I kind of start building. So the next point that's connected to the frame you're going to notice is going to be our handle. Do you see that? Okay. And as we look at our handle, do you notice that there is a connection to the frame and then there's going to be a connection to another link. So it's considered a simple link, but do you see how it has a little point of reference out here at the end of the handle? We would be interested in how far would the end of that handle be going, because that's going to directly relate to the manual process that we're going to have to take in order to actuate that shear. Okay. So what we're going to do is we're going to now represent this simple link on our kinematic diagram. And we might as well look over here, but you're going to notice that how they did that was they started at our frame and they connected right here at point, well, they're calling it point B. We'll talk about that in a little bit. And all that is it's just connecting these 2 points right here. And then because there's the special point of interest out here, we go all the way out and then back to our original point. So we make like this triangle that represents our handle. Okay. So the next thing we're going to add, and again, this is a sketch. We're going to go up to point B. It's going to be a filled in circle for that joint. And then we're going to go out to point X. And then let's see if I can get back to my original. Okay. Now, this is the second link that we're now connecting to our frame. So we're going to call this link number 2. So that's going to be a number with a circle around it. Now, I haven't glanced back at the kinematic diagram yet. When we start numbering the links that are connected to the frame, the order is kind of arbitrary, okay? If you call this link number 3, or if you call it number 4, it doesn't really matter, okay? But once you identify it, then any calculations you do, for instance, when we get to velocity, are going to have to correspond to that link. So if we look here, oh, they do number 2. So sometimes they do them out a little bit different order than going from the frame, but since frame was number 1, whatever link I draw in next, I always call that number 2. And it's going to be, it's for me, I always go from the frame. So that's going to be number 2. Then the next link that we're going to look at off of that handle is going to be the link that goes down to that shear. Okay. So we're going to sketch that link in place. So we're going to put that one, something like that. And on the end of it, it's going to connect to our shear. This is going to be link number 3. And again, it's just the next link kind of as I'm adding these. Now, our last link that we're going to be identifying here is going to be that shear. Now, the operation of that shear is going to be vertical only, right? It's constrained to going up and down, up and down. So that means that it's a slider, okay? And we represent a slider with a simple rectangle, and then we have to show the line of action, and I'll show you how to do that in just a bit. So at the end here, we're simply going to draw a rectangle, okay? We are representing this shear as a simple block, okay? It's a slider. Now, if you wanted to, you could add, and I don't think that would be unreasonable, if you wanted to add, like, you knew the size of that shear and you wanted to show where the blade was to maybe show how up and down that would be, the end of that blade could be a point of interest if, as the designer, you felt that that was important, okay? I want you to know that if you compare your diagrams to examples sometimes and you have some little bit of variations on them based on assumptions you're making based on the design, that's okay, all right? So you can change that shape slightly if it seems to make sense. But I'm just going to show it as a rectangle like they do in the example. Okay. Now, lastly, on a slider, we can't just leave it as a rectangle. We have to put what it's restricted to in terms of motion. So there is going to be then a vertical wall, and we show it with hatch on the side of it to represent that it's, if you would, part of the frame. Even though this part of the frame and this side over here are two different physical pieces, both of them do not move. So they really both function as one link, okay? And then we'll kind of get used to that. And this slider is going to be our link number 4 then. Okay. So each one of our physical links, including the frame, even though it may not be moving, is going to have a number with a circle around it. Number 1 will always be the frame. And then these 3, 2, 3, and 4 can be numbered in a different order if so chosen. I'm gonna look what they did. See, this is where it's like, why did you do that? So number 2 is the handle. They did number 4 as the connecting rod, and they did number 3 as the slider. I like to think of it in terms of, you know, the order that I'm connecting back to the frame. So that's why you're going to notice I use this convention. But again, if you number them a little bit differently, with the exception, the frame has to be number 1. It's okay, as long as you're consistent with how you know, call them out. Okay. So questions kind of on that one. So this is example 1.1. Example 1.1. So make sure that when you're uploading your practice problems, that this sketch is going to be part of what you hand in for me, okay, for those practice problems. And when you hand them in as practice problems, you can take a picture off of your phone if you have the Canvas app on your phone. Do many of you have that? And check your grades there. It's really easy to take a picture. What's nice is, I think my instructions will always say make a PDF, but within the last like 6-8 months, Canvas is updated so that you can upload a picture, okay? So like a JPEG, and you don't have to convert it to a PDF. Previous to that, it was only PDFs that, you know, I could see when they would come up. So now they allow us to do pictures, but make sure that they're readable, that they're not blurry, that there's enough light that I can see what you're trying to get across when you want to do the pictures, okay? All right, so this is a kinematic diagram, a simplified version of the shear that we see here in problem 1.1, okay? All right, let's, yes, question.
So we get back to lettering.
Oh, thank you for reminding me of that. You're right. I did not do the lettering here. That is an important part of our diagram. So not only do we have to identify each one of the mechanisms, thank you so much for reminding me of that, we need to also letter our joints. Now, here too, the lettering can be a little arbitrary, but most often, wherever you start with number 1, this is going to be your first joint. Joints are going to be capital letters. So A, for instance, is going to be my first joint off of my frame. And then I go B, C, and then whenever we have a slider, there is another joint. And that joint is going to be between the slider and the surface that it's sliding on. It is captured some way, somehow, that it has to go along that line of action, if you would. Okay, so A, B, C at each one of what we call the primary joints, and then D is going to be that sliding joint. Okay, thank you. So now we have a complete kinematic diagram with each one of the elements identified as far as drawing and numbered for each one of the link numbers, and then we have the joints lettered. Okay. So now let's look at our next example, which is going to be example 1.2. Example 1.2 is a pair of vice grips. This is a hand tool, okay? And we want to draw the kinematic diagram for this vice grips. Now, I happen to have a vice grips from home, okay? So I'm going to kind of move my book here. And I'm sure most all of you have either used or seen one of these. I know it's not hard to kind of identify, you know, how it works, but basically vice grips is just going to grab onto something. And we've got some mechanism business going on here to give us mechanical advantage. Now, as we look here, you're going to notice that the vice grips that they have, there is not an obvious frame here. There's not a part of this mechanism that bolts down or stays in the same position. It's a hand tool, okay? So what we need to do is identify or assign a frame, okay? And so in this case, we would take one of, you know, the sides here. The side that I'm going to, and what the book also identifies as the frame, is going to be this top handle right here. So it's kind of like we're going to hold it and we're going to allow everything else to move relative to it. So this is going to act as our frame, okay? So let's peek ahead at the diagram that they created, which is on the following page. So at the top of page 8, this is the kinematic diagram that they came up with, which looks, I would like to say it looks nothing like a vice grips, but it does represent in simplified format using the kinematic symbols that we just talked about in a way that shows the function and the motion of these elements. So let's look at what they have. So you're going to notice that there are 2 frame members here. okay, or frame connections. So the frame is identified by that half circle going down, okay? And they have it called out as number 1. It is only called out as number 1 once, okay? So what that represents is the 2 connections that I have here. I've got a connection up in the inside of my handle here on this one, and the other connection I have right here. So these represent those 2 frame connections, even though it's just 1 frame. So notice that they only call out the frame once, and our first connection they're calling out here is where A is and then where D is. They don't recall out the other one. So this is all 1, if you would, on top. And we don't show the handle. We just show the connections to the frame in that standard format, okay? Then, depending on where you want to start, okay, we maybe look at this jaw that's on the bottom here, okay? It is connected to the frame right there. And then it has kind of an oblong shape here. So the connection to its next joint is straight down. But points of interest, we would probably want to know, kind of like on here, how far that opens up and closes as I actuate that handle, okay? So a point of interest is going to be out here. So this is going to go from my frame, going to go down, over to the outside here, and then back. And that's the triangle that we are seeing represented right here. Okay, they're calling that member number 3. Like I said earlier, the numbers of the other remaining links on the mechanism are kind of arbitrary, but they're using number 3. And then point X is a point of interest, which would be the bottom, or it would be the teeth end of that bottom portion. The next part is going to be number 2, which is our handle, okay? So as we look at our handle, this is this guy right here, right there. Here's the connection to link number 2, okay? Here's the connection where it's gonna go up to the next link, okay? And then out here at the bottom, this is going to be another point of interest for us because this kind of identifies or represents how far I have to open up my hand. So there are different vice grips that are different lengths, right? And sizes. And if I'm going to want to use this to be able to actuate with a human hand, I've got to know how far that's going to be apart if it's going to be a reasonable distance, right? So this would be another point of interest out here that I would want for my mechanism. So if I go, see, back up on this illustration here, you're going to notice that this represents that handle with a point Y, a point of interest of Y, as the end of that handle. Okay. And then our connecting rod going straight back up to that top handle on our vice grips. So here, even though there's kind of this funny looking link here, it's just a straight line from my handle on the bottom up to our identified frame member connection at point D. Okay, on there. Now, we've sketched our first one. We've kind of gone through this process. We see, does anybody have any questions on why anything is called out here, the way that it's called out? What I want to do is I want to use this example to draw it on AutoCAD. Okay, draw it on AutoCAD. So what we're going to do now is we're going to pull up AutoCAD and we're going to create I'm going to call it a kinematic start file so that when you do your assignments and when we do other examples, we have a file that we're starting with and it kind of has all the layers and the elements that are going to be most popular for us. So I am going to open up AutoCAD. And for those who are in the room, or if you have your laptop available, you want to open up AutoCAD and we're going to create this start file so that whenever we have a kinematic diagram to create, we're just going to pull that file up and it's going to have the layers set up for us and all the sizes and such. All right. So I'm just going to do a new file. And if you wanted to, a lot of you had me for tech drafting last year, and we created WCTC inch templates. If you still have access to that, that's a good place to start. But I'm going to start just new. I'm just going to use the generic ACAD one, and we're going to put a couple layers in there because it's been a little while since we've done that. And we're just going to hit open. Okay. Now, what I'm going to do, now I have my cursor set up a little bit differently, just so it's easier for you guys to see. I'm going to go up to the very top here, and we are going to go to layer properties. When we click on layer properties, we want to create some layers so that it represents the elements that we're going to be creating. So the first one that I'm going to create, which is consistent with the ones that we've had in the past is, and I'm just going to select on the 0 layer. I'm going to hit enter. And now it's going to go into a text editing mode for me to add a new layer. Okay. And I'm going to call this object because this would be an object line layer. Now you'll notice that the color here, I'm going to leave it as white. If you want to change it to a different color, that's totally up to you. The line type is going to be continuous. And I'm going to change the line weight. I'm going to click on that. And I'm going to change the line weight to 0.5 millimeters, make it thicker. And I'm going to say, okay, so it's going to make it thicker. And that's all that we need to do on that layer. The next layer that we're going to do, okay, is going to be hatch layer. And I like that color for me to be yellow. I'm going to leave it at continuous, and I'm going to go back to the default line weight. Another layer that we're going to do is going to be notes, because that's going to be where we put our numbers and our letters of our joints. And I'm going to make that magenta. Again, you can pick whatever color you want. And then I'm going to leave it at the default line weight. That's totally fine. I'm trying to think if there's any other ones that I need. For right now, I think that should be good. Okay. So we'll leave those, and I'm going to close this, and I'm going to change my layer to object line layer. Okay. And what we're going to do is we're going to start a file where we're going to have these drawn out already. Okay. So we're going to have the frame member drawn out with the correct hatching and sizes and such. We're going to have a slider drawn out, and we're going to have some of this text in place already so that all you got to do is copy it over and move it where it needs to go. Okay. Rather than going into a brand new file and starting over each time and setting up your layers. Okay. So now that we have these layers here, let's do a quick file, save as. And what I want you to do, either on a jump drive or a flash drive, or if you're planning to access this outside of class, maybe save this on your OneDrive. All we are going to do, I think I got to go to my OneDrive. And I'm going to go to mechanical design, and I'm going to go to, where's my basic mechanisms? Here it is, kinematics and basic mechanisms. And I'm just going to call this kinematic start _start. And that's just, it's just a start file for us. It's going to be a DWG file for us so that when we pull that up, we're going to rename it, whatever example number, but it's going to have the layers already there for us, as well as some of these elements we're going to draw in just a little bit. So again, file, save as, navigate to where you want it to save. And I called it kinematic _start. And it's a regular DWG file. You can just hit save. Okay. I'll give you a little bit of time to do that, right? Okay. So now what we want to do is we want to put in some of these elements. So I'm on the object line layer, and one of the symbols that I'm going to find that's going to come up very often is going to be that frame symbol. Okay. So I want to just start off by drawing a line, and I'm going to make it a horizontal line. So if you don't have ortho on, you can put it on already, but I don't want it to be super big. So right now, I think I'm going to make this so that it's about 3/4 of an inch long. Okay. 0.75. All right. And I'm going to hit escape. And then I'm going to draw a circle. so that it's at the middle of that line. So if you need to shift right mouse button, go to midpoint and just draw a circle to the end there. So that's going to be the top of the arch, if you would, over that frame member. Then we're going to go down, I don't know, about that far. Let's see what 0.5 looks like. Yeah, 0.5 looks good. And I'm going to go down from that other side, 0.5. Okay. And then I'm going to trim away the parts that I don't need. So trim is going to be our circle here. And remember, it's going to be left click and drag across the parts you want to get rid of. Okay. And then I'm going to draw another line. I'm going to start out and I want to kind of activate the left side. And I'm going to go in line with that. And I'm simply going to go across and I don't know, about 1.5-ish. Yeah. Something like that. Doesn't have to be perfect. And then I'm going to add a rectangle. I'm going to start in that upper left-hand corner, kind of go in line with this one, and maybe go down about like that. Okay. That rectangle is just going to be used, if you would, to house our hatching at the bottom. Now what I'm going to do is I'm going to change my layer to hatch. And I'm going to use the hatch function. And I'm going to click inside that rectangle that we just created. Left click. Now, for me right now, as I look at this, that hatching is a good size. You don't want it to be too close, but you don't want it to be too far apart. So hopefully yours is about, mine's a 1 scale. Hopefully yours is about that same size. Okay. If you need to change that scale, it's right here. You can increase it or decrease it if needed. Okay. Yes. Yep. So to cross hatch, I'm gonna close this out. I'm gonna get rid of mine right here. Delete. So you have to have a closed rectangle in this case. There's the hatch right here in the draw menu. Do you see it? You're gonna click on that and you're just gonna go into the inside and it should activate it. And then left click. And then, like I said, you can change the scale if you need to. It's ANSI 131. Don't use any fancy business, okay? We're just going to use the regular ANSI 131. And then we're just going to hit close to accept it. Now what I'm going to do is I don't need the outside of that rectangle. So I'm going to click on the outside of that rectangle and just delete it so that what's left over is the hatching as we see right here without it being enclosed. That's typically how we show it. I'm going to do a quick file save so I don't lose this. The next thing I'm going to do is I'm going to put the dot in the middle for the pin connection. So I am going to do a circle. I'm going to activate the center of that arch and we're just going to make it about, I don't know, 0.125. Let's see. Yep, that looks pretty good. Kind of mad at myself. I'm going to click on that. I didn't change my layer back to the object line layer. So you can just click on it, put it on the object line layer, and then change to the object line. Now, all of our joints are always filled in, okay? So go back to the hatch layer. I should have done that. They're always filled in. So we're going to rehatch in the inside of our circle, but this time we're going to make it solid. Okay. And then we're just going to hit OK. And I'm going to do a file save. And now we have our kinematic start file already has automatically drawn our frame member. Okay. The next type of element that we're going to put in here is going to be a sliding joint. Okay. If you recall, a sliding joint is going to be a rectangle. Okay. That is then going to have a horizontal or a vertical line. I'm going to draw it in its horizontal orientation. So we're just going to show a rectangle. And oopsie, I want to go on my object line layer to start. Zoom in here. So I'm going to do a rectangle about that big. So looks like about 1 inch by 1/2 inch. Right about there. Okay. And this doesn't have to be perfect sizing. It's just really just to get us a good size based on, you know, what we have here in terms of the frame. The next thing that I want to do is I'm always going to have a connection to my slider in the middle of the rectangle. So I am going to create a line. I'm going to turn off my ortho and I am going to go to the diagonal, hit escape, click the line again and do the other diagonal. All I want to do is I want to find where is the center of that rectangle that I just created. Okay. And it's going to be at the intersection of those two diagonal lines. Now at that intersection, I want to create a joint. So I am going to do a circle intersection. Oopsie. And I want that to be 0.125 radius. Okay. Now I'm going to erase those two diagonal lines because I don't need them anymore. I just needed them to find my center. And then I'm going to hatch. So I'm going to change my layer to hatch. And I'm going to go on the inside of that dot, make sure that it's solid, and then hit OK or close. Now, lastly, I need to give it an orientation along the longer leg of that rectangle. So I'm going to move this over a little bit. Okay. And we are going to draw a line and I'm going to kind of extend it further in one direction than the other. And now I can see I need to change my layer again. So I'm going to select on that line, change it to the object line. Okay. And now I'm going to create another rectangle. I'm going to leave it on the hatch layer. I'm going to create another rectangle so that it's underneath here for about that same, activate that corner, right about there. And now we're going to do that same hatching, this time back to the ANSI 31 or ANS 131. Click on that. Scale of 1. Okay. And then I'm going to select the outside of that rectangle and I'm going to delete it so it looks like this. Okay. And I'm going to do a save. So we want to have a frame member and a sliding joint available for us to use if we need to. Okay, so kind of already done. Any questions so far? If it's been a little while since you've done AutoCAD, that's okay. It's kind of fun to get back into it again. All right, the last thing we want to do is we want to create some text so that all we have to do is kind of move it where it needs to go. So I want you to create a 1, 2, 3, and a 4, because most often we're going to be working with 4-bar mechanisms with circles around them, and then an A, B, C, and a D. Okay. So I'm going to change my layer to notes. We're going to go to the text multi-text, and we're just going to create a rectangle. Okay. And this is just to put it gives us kind of the size of the box that we're going to be using. Right now, we're going to leave all of the settings for what we have in our lettering up there as is. I'm not going to really change anything. I just want to create the number 1. Okay. And then I'm going to left click on the outside. If you hit enter, it's going to add another line in that text box. I just want the number 1. Now, as I look at this, okay, I'm just going to randomly move this over to, I'm going to move it over here. And in relationship to the size that we have here, I feel like it's a little small. Okay. So all I'm going to do is I'm going to scale this letter to be a little bit bigger. All right. To do that, I'm going to hit the scale function on my ribbon, which is right above the modify. I'm going to select the object, enter. It's going to ask me for a base point. I'm going to put it right at the base of the number 1 here. And now what I'm going to do is I'm going to kind of go up at an angle and I'm going to make it a little bit bigger than what it is, so that the number looks a little bit more proportional to the size. We don't want it too big. We don't want it too small. Does that make sense? Did you kind of make yours? Did you have to make yours a little bit bigger? And then now what we're going to do is we're going to put a circle around it. So I'm going to do the circle command. I'm going to go right about in the middle of that letter. Okay, it's not going to snap to it because there's nothing there to snap to. And I just want to put a circle around that letter, just like that. Okay. Now I want to do a 1, 2, 3, and a 4. So I'm going to do a copy now. I'm going to copy the letter and the circle. I'm going to hit enter because I just want those two selected. And now I want my base position is going to be where this is right now. And then I'm going to turn on my ortho so they're all in line. 2. I'm going to left click each time that I want to leave a copy. And I want 1, 2, 3, and 4. That's all that I want. And then I'm going to hit escape to be done. Okay. And then I don't want all ones. I want a 2, a 3, and a 4. So now I'm just going to double click on the first one here. Whoops, double click. It should go into text editing mode. You can hit backspace and hit number 2. And then you're going to left click on the outside. I'm going to double click on the next one. Backspace, number 3, and left click outside. And then double click on the 4th one. Backspace, number 4, and left click outside. And now I'm going to do a file save. Okay. And you can arrange this on your screen however you want. I'm just kind of putting them there for right now because they're just there so that when I create a diagram, now I can move these where I want them to go. Now I want to do that same thing for the letters. I need A, B, C, and D. So I am going to copy. I guess I'll use the thing up here. I'm going to do copy, and I'm going to copy just the letters, just the numbers. I'm sorry, not the circles. So I'm going to copy 1, 2, 3, 4, left click on each one. Once I have all 4 of those selected, I'm going to hit enter, and my base position is going to be right about there. And I'm just going to go straight up, and I'm going to put a copy above. Now I'm going to go in, I'm going to double click, and I'm going to change the number 1, backspace, to capital A. It's capital A. Left click on the outside. Double click on 2, backspace, and this is going to be B. Double click on 3. Change that to C. Left click on the outside, double click on the 4, and change that to capital D. And then we're going to do another file save. There we go. Now, if you have a diagram where you need to add dimensions to it, because we are going to be, looking at doing displacements, those would go on the notes layer as well. Anything that is like text or dimension related goes on those notes. So now save it one more time to your kinematic start. Okay, so now what you have already available to you is the only thing that you're going to do now is draw any lines in between, but that's going to depend on the information that you get. But now you've got a slider in place and you've got a frame member in place, as well as the standard labels for each one. So each time you start a new example, you're going to pull up your kinematic start. And the first thing you're going to do is you're going to resave it as whatever that example is. So our example for this one, we're going to redraw example 1.2. We're going to say file, save as, and we're going to say example 1_2. And then we're going to say save. Now you'll notice at the top here, it changed it to example 1_2. And now I can start drawing my diagram in AutoCAD. Okay, so setting up that start file. Before we get into actually doing the work on example 1.2, I've been talking for a little bit. I need to take a little bit of a break. So why don't we take another 10-minute break here, And I need to grab something and then we'll be back to show how we would create the diagram for example 1.2 in AutoCAD. Okay.